Okay, now we come to next question, and this is the similar question which we have done before. Integration e to the power x square plus 1 upon x plus 1 square into dx. Okay, here again we will first try to simplify this. Okay, to simplify this, I will try to cancel out a term from the denominator, like I have here x plus 1 to the power 2. I will try to make some term in the numerator so that this x plus 1 cancelled out. But here I have in numerator x square plus 1. So here I can't apply any formula. But what I can do is, if I add 1 and subtract 1, I will get x square minus 1 here somehow. And this x square minus 1, I can apply the formula, will be x minus 1 into x plus 1. And then I will cancel out this x plus 1 from x plus 1 in the denominator. So one power will be cancelled out. Okay, let us try this. Okay, now what I am doing, e to the power x is here. I am subtracting 1 and adding 1. And in the denominator, I have x plus 1 to the power 2 dx. Okay, now I will separate this into two terms, e to the power x square minus 1. Okay, I have this plus 1 also here. So here minus 1 plus 1 and this plus 1 which we already have. So now x plus 1 square dx plus 2 into e to the power x upon x plus 1 whole square dx. Okay, now we simplify this, e to the power x into x minus 1 into x plus 1 upon x plus 1 whole square dx plus 2 e to the power x upon x plus 1 whole square dx. Now this x plus 1 cancelled out by 1 x plus 1 from the denominator. Now we get e to the power x into x minus 1 upon x minus 1 dx plus 2 e to the power x upon x plus 1 whole square dx. Sorry, here we have x plus 1 in the denominator. Now this first term can be split into two parts. Let us split it into two parts. X into e to the power x upon x plus 1 dx minus e to the power x upon x plus 1 dx minus 2 e to the power x upon x plus 1 whole square dx. Okay, again we will simplify this. How? What we'll do? We will add 1 and subtract 1. So it will become x plus 1 and minus 1 e to the power x upon x plus 1 dx minus e to the power x upon x plus 1 dx minus twice of e to the power x upon x plus 1 whole square dx. Again we will separate these two terms. So we will get x plus 1 e to the power x upon x plus 1 dx minus e to the power x. Oh, this actually this is plus here, so this should be plus minus e to the power x dx upon x plus 1. And minus e to the power x upon x plus 1 dx minus 2 e to the power x upon x plus 1 whole square dx. Now this is cancelled out and we get e to the power x dx minus twice of e to the power x upon x plus 1 dx minus this twice of e to the power x upon x plus 1 whole square dx. What we will do now, we will apply by parts here. So first is for here, first function is 1 upon x plus 1 and second function is e to the power x. After applying the formula, we get integration of e to the power x is e to the power x minus 2 is here outside the integral. So first function is 1 upon x plus 1 and recall we will not solve this integral because this will be cancelled out. We will solve only second last. So 1 upon x plus 1 integration of e to the power x dx minus integral differentiation of 1 upon x plus 1 integration of e to the power x and then integration of their products, and last term is 2 into e to the power x upon x plus 1 whole square dx plus c, because we have applied the integration of this e to the power x, so we will get plus c here. Now this is e to the power x minus 2 upon x plus 1 integral of e to the power x is e to the power x. Now this minus and this minus, after their product, after their multiplication, we will get plus integration of minus 1 upon x plus 1 whole square e to the power x dx. Sorry, actually this one is this is not minus here, this is plus, because here we have plus. This is plus twice of, and here 2 also, 2 e to the power x upon x plus 1 whole square dx plus c, e to the power x minus 2 into e to the power x upon x plus 1. These two terms cancelled out with each other, so we get plus c. This is our answer. Now we come to next question. Integration cos inverse 1 minus x square upon 1 plus x square into dx. To simplify this, let us assume x is equal to tan t or tan theta. Why? Because here we can see there is term 1 minus x square upon 1 plus x square, and we know that 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. So here we have cos inverse, so we want this to be something cos, term of cos, so that cos inverse cancelled out, cancel cos, and rest of 2 theta here will be left. So x is equal to tan theta. Now after differentiating, dx is equal to sec square theta d theta. Okay, now we put these values in our integration, we get cos inverse 1 minus tan square theta upon 1 plus tan square theta into sec square theta d theta, because dx is equal to sec square theta d theta. Now cos inverse, this is the formula of cos 2 theta. Cos 2 theta and sec square theta d theta. Now cos inverse is inverse function of cos theta, cos, so we will get 2 theta into sec square theta d theta. This can be written as 2 integration theta sec square theta d theta. This can be solved by parts. So theta is first function and sec square theta is second function, and using the formula we get 2 is here, theta sec square theta d theta minus differentiation of theta with respect to theta, integration of sec square theta d theta and integration of their product. So we will get theta, integration of sec square theta is tan theta minus differentiation of theta with respect to theta is 1, and integration of this sec square theta is tan theta d theta plus c. So we get here 2 theta tan theta minus log sec theta, because we know integration of tan theta is log sec theta, plus c. Now we can put the value of theta here, or say tan theta. Okay, we know that sec square theta is equal to, here we know that sec square theta is 1 plus tan square theta. So sec theta is under root 1 plus tan square theta. Now we know that tan theta is x, so sec theta is equal to under root 1 plus x square. Now here if x is equal to tan theta, so theta is equal to tan inverse x. So theta is tan inverse x into tan theta is simply x minus log sec theta is under root 1 plus x square plus c. This is answer. Now next question, integration sine inverse 3x minus 4x cube dx. Now here we can see that here we have sine inverse, so we want this term to be in terms of something sine. So clearly recall the formula of sine 3 theta. Sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So here we can replace this x by sine theta. So let us consider, let x is equal to sine theta. So theta is equal to sine inverse x. We will need it later. But here dx is equal to cos theta d theta. After replacing these values in our integral, we will get sine inverse 3 sine theta minus 4 sine cube theta d theta. Not only d theta but d theta. This dx is cos theta into d theta. So cos theta d theta. Okay, now we get sine inverse sine 3 theta cos theta d theta. This is equal to 3 theta cos theta d theta. Cos theta is first, theta is first and cos theta is second. Using integration by parts, we get theta integration of cos theta minus differentiation of theta and integration of cos theta with respect to theta and again integration. This is equal to 3 theta sine theta minus integration of 1 into sine theta d theta plus c, which is equal to 3 theta sine theta minus 3 and integration of sine theta d theta is minus cos theta. So after multiplying this minus to that minus, we get plus cos theta plus c. Now we can replace these values of theta. So we get 3. Theta is sine inverse x plus 3. Now we know that here cos square theta is equal to 1 minus sine square theta. So cos theta is equal to under root 1 minus sine square theta. So this is equal to 1 minus x square. So under root 1 minus x square plus c. This is answer. Next question is integration tan cube x into sec cube x dx. Okay, here we have two possibilities. We can take tan x to be t or sec x to be t. If we take tan x is equal to t, then sec square x into dx will become dt. But here one sec x will be remained. So we will take sec x is equal to t. Now differentiating it, we get sec x tan x dx is equal to dt. So this would be better rather than letting t is equal to tan x. So this will simplify our integration. So in this case, first we will rewrite our given integration so that this is separated. So tan square x into sec square x into sec x tan x dx. So here we can check effectively the power of sec x will be 3 and power of tan x will be 3. So it is same. Now we have assumed that sec x is equal to t. So we should not have tan here. So we will apply this equation that 1 plus tan square t is equal to sec square t. So tan square t is equal to sec square t minus 1. So here we will get sec square x minus 1 into sec square x into this sec x tan x dx. Now we can put these values here in our integral. So we will get t square minus 1 into t dt. We will simplify this. We will get t cube minus t square dt. After separating them, we will get t cube dt minus t square dt. So integration of t cube is t to the power 4 upon 4 minus t cube upon 3 plus c. After putting the values of t back, so it is sec x to the power 4 upon 4 minus sec x to the power 3 upon 3 plus c. This is our answer. Now next question. Next question is integral of e to the power ax cos bx dx. So here clearly we will apply integration by parts. So exponential function comes in this islet at last. So e to the power x will be second function and this will be first function. So let us apply the formula, and I am assuming this integration to be I. So I is equal to cos bx e to the power ax dx minus d over dx cos bx integral of e to the power ax dx dx. Now this is equal to cos bx e to the power ax upon a minus integration. So differentiation of cos bx is minus of sin b into sin bx. So this minus will be plus b sin bx, and integration of e to the power ax is e to the power ax upon a dx. So this I is equal to e to the power ax cos bx upon a plus b upon a integration e to the power ax not cos, this is sin bx dx. Now again for this integral, this is first and this is second, and we will solve this. So I is equal to e to the power ax upon a cos bx plus b by a sin bx integration e to the power ax dx minus integration differentiation of sin bx and integration of e to the power ax dx dx plus c. Here also plus c. So I is equal to e to the power ax upon a cos bx plus b by a sin bx e to the power ax upon a minus b by a integration, this is b cos bx and e to the power ax upon a dx plus c. This is I is equal to e to the power ax upon a cos bx plus b upon a square sine bx e to the power ax, and this is minus b upon a square, b square upon a square e to the power ax cos bx dx plus c. Now clearly from here we can see that this integration is again equal to I. So this I is equal to e to the power ax cos bx upon a plus b upon a square e to the power ax sine bx minus b square upon a square into I plus c. So this term, if we take this term to the left hand side, we will get I 1 plus b square upon a square is equal to e to the power ax upon a square. If we take a square to common, it is a cos bx plus b sine bx plus c. Now I a square plus b square is equal to e to the power ax upon a square a cos bx plus b sine bx plus c. So this a square gets cancelled out and we get I is equal to e to the power ax upon a square plus b square into a cos bx plus b sine bx plus c prime, where this c prime is equal to c upon a square plus b square. So this is our answer.